Hello again, CS111 students. This is my problem set instructions video for problem set 1, the time profiler task. I'm going to go ahead and transition here so you can see my screen. This is task 3, and there are videos already for tasks 1 and 2. Again, these videos, I'm just walking through the instructions for the problem set that are already on the web. You do not need to watch the video if you're happy to read the description. There's no new content in this video. I'm just walking through what's written here and describing it, but that's definitely helpful for some people. So feel free to watch it if you want. All right, let me go ahead and jump into this. This is task 3, the time profiler. And this is, in some ways, the most complicated task, where we ask you to write some of your own code that kind of solves a miniature problem. It's very basic because we haven't learned that much yet in this class, but it's your first step at problem solving by writing code. This task is a partner task, just like task 2 was, so feel free to work with a partner. We encourage you to find a partner and work with a partner on this. And as usual, I'm going to go ahead and open up the rubric, and we can just review it. You can see that this task has both procedure requirements and behavior requirements. So requirements about what is in your code, and requirements about what your code does, right? Those are two different things. You can have some great code that, because of a little error somewhere, doesn't work at all. And you can have some code that works very well, but is like really a mess inside. So we have requirements on both sides of the fence there. For the procedure requirements, right, these generally are useful in terms of giving you hints about ways to solve the problem. Right, when it says, okay, you have to call input in exactly 6 places, right? That means there have to be 6 lines of code where you call input, no more, no less, right? That's a big hint about how to solve the problem. That can prevent you from going astray in various ways. So pay attention to these, and it's not a bad thing to sort of scan these when you start the task, and then come back to them and use them as a checklist at the end to say, well, am I really done with this? Did I get all the things I wanted? Okay. So there's core goals of calling input float and maybe round as an extra goal. There are behavior requirements. The core goals here are basically that the results of running your file are correct for various different inputs, and we'll see what that means in a second. And then there's an extra input as well. So if we go back to the description, let's just start at the top. So again, it says put all your work into a file called timeprofiler.py. Capital P is important, lowercase rest is important, right? Case sensitive. And this is a new file that you're going to create. We do not provide a starter file for this task. You're going to create it entirely from scratch. It's all your own code. So the premise of this problem, right, to give you a simple problem to solve in this first week, is that time is important to Wellesley students. You want to use your time wisely. Time is important to everybody. And this time profiler program is going to help you calculate how much time you spend per week on various different activities, right? And if I ask you, how much time per week do you spend on class? You might say, I don't know, I have to add up this and that, right? And that's something a program can do for you, right? Is add numbers up. If I ask you, how many classes do you have? And how many hours per week do you spend in each individual class? Those are easier questions to answer, right? So the idea is that this program will ask you a few questions that are easy to answer, right? Like, how many hours do you sleep each night? And then it'll translate those numbers into units of time per week to give you an overview of the total time you spend on these things per week. There's 4 categories that we'll use. And again, you might be tempted to make this program better. Maybe there's a 5th category you want to add or something. We would love to encourage that, but in order to keep the grading manageable, and it is automatically graded, we want you to sort of stick exactly with what we're asking you to do, down to even like the specific wording of each question. if you want to experiment and do your own thing and do more design in terms of the programming thing, we'll have opportunities for that in later tasks. And some of the tasks, like the scene.py task from this problem set where you can draw something, you do have a lot of freedom to do what you want. But in this task, we're asking you to do something very specific. So the 4 categories are: 1, classwork. And this includes not just time in class, but also homework time, right? The time that you're watching this video is time you're spending on classwork, right? The time that you're going to program these problem sets is going to be a significant amount of time outside of class each week. What this programming is going to assume, though, is that for every hour in class, there are 2 hours of homework time required, right? So essentially, we're going to be multiplying to get the total number of amount of class time. And we can just ask the person, how much time do you spend in class, rather than asking them to do the estimation of all this stuff, right? Okay, category 2, activities outside of class. You might be an athlete, a musician, be in clubs, you might have a job. And we're going to ask the user to actually name this category. So they're going to supply a name for it, and then we're going to use that name in our program. We have an amount of time for sleep. That's important, right? And again, it's kind of not that hard to answer the question on average, how much time do you sleep per night? If you ask me per week, I could multiply by 7, but it's harder for me to do, and it's nice to have the program do it for you. Finally, free time, right? So anything that's not those other 3 categories, we lump into free time, and we can report how much time is left over if we just add up the number of hours in a week. So every time you run the program, right, and then you press that green triangle button to run it, it should prompt the user to enter information about these activities and display a little printout of the results. So we have some examples shown here about what that needs to look like. And again, it should be exact down to the individual spacing, capitalization, quotation marks, phrasing of each question, if you want that perfect score. We try to be a little bit fuzzy about the checking for those core goals. So you can have some differences, and probably still get the core goals, but the extra goals are pretty exact in how they check things. In these examples, again, as in previous examples, the blue text is text that you type in, or the user types in, right? So in this example, the program, printed out, "What is your name?" ? And then it waited. And then if you type Valentina, and then you type 5, and then 2.5, and then fun, and then 15, and then 8, if you do all these things, then this is what it will look like. If you did something different, it would look different. So this is an example. There's these prompts. We ask for your name. We ask how many classes you're taking. We ask time in class per week this semester. We ask, what are we going to call the everything outside of class category? How many hours per week do you spend? And then how many hours per day, right, do you sleep? And based on these answers, we come up with these estimates, right? So, okay, 2.5 hours in class per week, per class, right, times 5 classes translates to 37.5 class hours, right? And again, that's because we assume that, well, 2.5 hours in class means the extra 5 hours of homework, so 7.5 hours times 5 classes, that's how we get this number. And then, for this extra category, we just ask you to estimate the per week time directly, so that's a 15. And then for this hours per day of sleep, 8 translates into 56 hours per sleep per week. Notice that all of these are printed with decimal points, and in these cases down here, you'll see no more than 2 digits after the decimal point. That's one of these extra goals to round things off. Finally, this 59.5 free hours, that's what you get if you subtract these 3 numbers from the total number of hours in a week. So this is one example, and then here's another example, right? If we enter these inputs, this is the output we get. Here's another example, these inputs, this output. So we're giving you sort of 3 examples that you can use to triangulate, well, what does this program do for these different cases? And then in the rubric, you'll see these tests are referring to the Valentina input, the Emma input, the Sophia input. There is this extra input, which is an extra goal, right? That you have truly taken these things and generalized from these 3 examples to a solution that really works in a lot of different cases. We're not going to tell you what that input is, but we're going to test you with some other reasonable input, right? We're not going to do anything silly like type a name instead of a number one of these places, or give you some, fractional number of classes, although we might give you fractional number of hours per class per week. But to get the 100% credit, all the extra goals, you're going to have to make sure your program behaves as expected for that test. Right? We didn't tell you explicitly what the expectation is, but we implied what it is by giving you these 3 explicit criteria. All right. So there's descriptions of some of the things I've been talking about. It talks about the rounding to 2 decimal places. It talks about asking the user for the name of the category and then using that again. So if they put work here, it should say work here, and it should say work here. Okay. Okay, it has some instructions about how to work on it, right? So start by downloading this PSO1 folder, then create a time profiler.py program in that folder. And like I was saying, you want it to be exactly like those examples. We recommend this idea of incremental development, right? Incremental step by step. So you want to take the problem and break it into smaller problems, right? And a smaller problem might be, just this line up here and this line down here that uses that name, right? So a smaller problem doesn't have to be a sort of piece of the whole thing that's contiguous, but it can be like, well, look, this line of code and this line of code, the lines of code that produce those outputs are probably related. Let me start with just that, right? So let me build a program that does just this. Right? And once I've done that, well, I could add maybe the sleep hours, right? And so now my program does these 2 parts of the whole thing, right? And if you do it this way and you sort of eliminate all of the bugs and get things working at each step, it typically saves a lot of time over trying to write the entire program, right? Finding out that, oh, I wrote the whole thing, now I'm running it, now it doesn't quite work somehow. And then starting to fix things from there. Right? After you add sleep, you could add this what should we call kind of thing. And do it bit by bit. Okay. So this is just an example of a strategy that you could use. You could do things in a different order, but we recommend doing them piece by piece and breaking it down. And that's really one of the skills that we're trying to teach you in this class, in this case by example. Of how to break a problem down into smaller steps, solve those smaller problems, and then combine them into a solution to the whole problem, rather than trying to just tackle the whole thing at once. All right, to round out this video, let me go through these notes at the end. Again, these note sections of the problem sets are typically useful hints. So your time profiler.py file must start with comments at the top, identifying the author, username, problem set, number, file name, and date. All of our files that we're submitting in this class will have this kind of comment structure. The ones that we provide you, you'll have to fill them in. The ones that you create yourself, you'll have to add them. And so this is just an example of that. So these are the features that you should use in this program. And this list is kind of a hint because it's saying like, hey, this is what you need to be able to solve this problem. You don't need to use anything beyond this. And these features are talked about in Lab 1 and in Lecture 2. So the arithmetic operators, the string operators, some of them are the same operator, right? But they behave differently depending on the types you use them with. And you don't necessarily need all of these for this task. These are just sort of the set of things you might need. And then there's these built-in functions. Float, int, len, max, print, int, input, round, and string. You should not use anything that we haven't studied yet. Some of you may have already have some knowledge of Python or other programming languages, and feel like using a loop or a conditional or other things that we're going to study in the coming weeks. But I guarantee you do not need any of those things for this program. And to keep things simple, we want you to not use them. This is mentioning what I've already sort of gone over, that like every little thing is important if you want to have that completely correct 100% score. There's a link here to a difference checker website. I'll just show you real quick. This is what it looks like if it loads. And what you can do is you can paste text in these two boxes and then find the differences. And it will highlight any little minute differences between those two pieces of text, so you don't have to sort of like rack your brain scanning and being like, are all the spaces the same? Are all the quotation marks the same? This will highlight them for you. So this is a useful site for this task and for other tasks in this class. Okay, another note here, the final note, is that you may assume that the inputs are sensible. So we don't require your program to be so robust that no matter what the user types, it'll somehow keep working, right? What if the user doesn't type in their name and they just press enter? What if the program asks how many classes are you taking and they write FOUR, 4, but as like a string, not as the number 4, right? Python won't be able to handle that very easily. And we haven't really discussed all the techniques for handling something like that. So when we say you may assume the inputs are sensible, what we mean is we will only test your program with inputs that follow this list of sensible rules. And if your program does something weird when you give it something that is outside of those rules, that's totally fine. We're not gonna grade you on that. It's not gonna impact your grade, and your program will count as just as correct as somebody else's program that does something different for those weird inputs. So here is what makes an input sensible. So the name may be any string, including the empty string. The number of classes is assumed to be an integer. This is a rather tight restriction. Some of you might be taking half classes, so technically their number of classes would be 3.5, but just for simplicity, you can assume that it's an integer. That's what we're going to use for testing. The average time in class per week is expected to be a number, but might be an integer or floating point number. We're not guaranteeing it'll be an integer. The number of extracurricular hours per week is expected to be a number, integer or floating point number. The number of hours slept per day is again expected to be a number. And then we also assume that the total number of inputted hours, or their sum, is not larger than the total number of hours in a week, which is 168 hours, right? You can imagine if somebody said, well, how much do you spend on stuff outside of class? And they say, oh, you know, I spend my time astral projecting, and I spend 300 hours a week doing that. That would be super interesting, but it would lead our program to weird behavior, right? So we're not going to test with something like that. That would lead to a negative value for the amount of free hours. And then the other assumption you can make is that the string that the user inputs for the everything outside of class is not the same as one of the other category names, class, sleep, or crew. That's not necessarily terribly important, but that's what we have imposed as the restrictions on ourselves that you can sort of safely assume will be the case. So that's the end of this video for task 3. I hope it's helpful, and good luck on this first problem set.